Example number 5. We want to start out the same way we always do and ask ourselves, is there a greatest common factor? Well, I think the greatest common factor is kind of screaming at us in this one. I see a 5, 5, 5, and 5, thinking that maybe 5 is a GCF. I do notice that the last term does not have a P in it, so that means that we will not be able to use P as part of our GCF, only the 5. So I'm going to divide everything by 5. Bring that out as a GCF and then say what I have left. And what I have left is going to be P cubed plus P minus P squared and minus 1. Let's count how many terms there are. There looks like a lot. 1, 2, 3, 4. Taking a peek down here at my chart, if I have 4 terms left, we're going to be using grouping to factor. So remember I told you that we were going to do grouping using our factor box. So you could either note, let's make a note that we did GCF first. And then now we're going to use a factor box. So this is going to be our factor box over here. And that's how we'll come up with our second try at this. All right, so here's how a factor box works. It works very similar to the box here that we've used in the Xbox method, but honestly, it doesn't matter where you put these terms. There's already 4 of them, notice. We didn't have to create this, those 2 terms that went here using an XPuzzle. I'm just going to write the different terms in the boxes, and it really doesn't matter which box has which factor. So I'm going to say P cubed, P minus P squared, and minus 1. And now I'm ready to look for GCFs across each row and down each column, just like I did with my Xbox method up here and previously in example 1. We just didn't have to do the X part of the Xbox first because we already have 4 terms. So it's actually easier to factor a polynomial than a quadratic. Who would have thought? P squared and P, I have a P. Negative P squared and negative 1, well, I'm going to have a negative 1. There's nothing in common except that negative sign, basically. P cubed and P squared will be a P squared. P and negative 1, well, that's just going to be a 1. Not a negative this time because remember, the sign is dictated by this term that I just wrote above. Okay, so let's go ahead and rewrite this. The 5 is going to just kind of come along for the ride at this point. And I want to write my other factors now, P minus 1 and P squared plus 1. And I'm going to notice that this is a monomial factor. P minus 1 is linear. Remember, that means it has an implied 1 here, but nothing bigger. And then P squared plus 1. I think we have talked about that quite a bit to where we know if we have a sum of 2 squares, P squared being the perfect square of P, and 1 being the perfect square of 1, we can't factor a sum of 2 squares. So we're going to make ourselves a note that we can't factor that. And so if we can't factor it, we have a linear term, we have a monomial term. That meets all of the criteria for saying that we are done with this one.